Welcome to .NET Conf. My name is Maxime Rouillet, and I'm a cloud developer advocate for Microsoft. I've been doing this for only the past 2 months, and I've got to meet some great people around here. And our focus is to make sure that we make the cloud the best experience for you guys. So I've been working different titles in the industry for the past 15 years, from small to big companies. And my plan today is to basically tackle how .NET Core, microservices, and Service Fabric can all come together and make your application more powerful, faster, and more reliable. I would love for you to hit me up on Twitter at my handle that is right now visible on the screen. And if you want to tweet with us, you can always use this hashtag called AZDev, and we're always going to be there to answer all your questions. So what are you expecting to learn from this session today? Well, what is a microservice architecture, and why is it relevant? And what it even is Service Fabric, really, and how to get started with microservices using .NET Core and Azure Service Fabric. Finally, unleashing the power of your microservice applications, we'll show you how. And where does containers fit in all this? Probably all heard all the jazz about containers and stuff. And we'll see how that fits in with Service Fabric, and if you even should consider containers. So why a microservice architecture? Well, microservices provide long-term agility. It enables you to have better maintainability of your application by providing large, complex, and highly scalable systems with more options in a way to be more resilient to failure. Let's create an application that is more independent, that you can deploy services in a more autonomous way. So that if one services crash or one services needs to have more power, it's always possible, which is not possible with monolithic applications. Talking about monolithic application, really, we got two approaches really in this scenario that we're going to take a look at. The monolithic approach is that your application is going to be containing all the domain and the specific functionality of your app, and all those layers all coupled together in your application. So the only way for you to scale them out is to add either more servers, more VMs, or more containers, unless you start really splitting them up, which brings us to the microservice approach. Microservice applications separates functionality into different smaller services. So if you're having a shopping cart, the shopping cart might be a different service. And the way we're going to be splitting them up is that each services can take their own part of the different VMs and different servers that is available for you. So if one part of the applications is more intensive and require more power, it's always possible to just scale that part of the application out without scaling the rest. So how do you handle state in a microservice architecture? This is a really tough problem, because you want to make sure that you're not going to be like getting on the other feet of the other application and not mixing up the data and synchronizing the states and the schemas. So that's the kind of problem you find in a state of a monolithic approach. Is you're going to have one application that is going to contact a bunch of services, and all those services are going to be linked to one or multiple databases. And each of those services really, as I saw it in a lot of businesses, are all going to talk to a different database, whatever if they are the actual authority on that data. So how do we see that on a microservice approach? Well, so you have to see it as a graph of interconnected services. If you have a service that is responsible for a basket, well, they have their own data source. And nobody else but the microservice itself is going to access this data source. If you have an identity server, this is also going to have its own data source. It's not going to be mixing up with the other data. So the front end is going to be a stateless presentation service, and we have a bunch of stateless backend service that is possible. In some states, microservices allows you also to have what we call a stateful service. If your application is intensive on reads, a stateful service is basically having data that is in memory. The best data and the fastest way to get it is when you don't even have to hit the network connections. Of course, you do have to hit some connections at some point, but if you already have it in memory, you don't have to fetch it from the database, and the database is one less dependency to rely on. So we're going to see how Service Fabric can actually help you out with that. So there's a reference application called the eShop on containers that we're going to get on that demo a little bit later. And basically, the client apps that we have right now is based on Xamarin Forms. And you're going to see the traditional web app. And there's also a single page application. So we all have those scenarios covered for you. And we also offer a Docker host for all those microservices. So as you see on the right, we have an identity microservice that's going to be taking charge of authenticating the users. So as every e-commerce, you want to have users that are going to be logging in, passing orders, and ordering stuff. So to first see what you're going to buy, you're going to need a catalog microservice. The catalog is going to be the repository of all the products, but it's not necessarily a database that people are going to read. They're going to talk to the catalog service. And all of those services, and there's many of them, are all going to talk through the event bus. And this event bus is basically how you're going to synchronize all the different data when you're ordering a product and you want to update the inventory, or your basket wanted to know what the product is. Well, it's going to talk to the catalog. Of course, the application can talk to the microservices directly, but we'll get to that in a few seconds. So how does Service Fabric makes it easy to do all of this? Well, first, it helps you with rolling upgrades, because as you just realized, we can publish microservices on multiple platforms and on different machines, on different nodes. And the problem is, when you try to upgrade your applications, you want to make sure that all the copies of this application are updated. You don't want to have one version that is rolling on a previous version. Otherwise, you're getting into some weird bugs where there's only a few applications that behave properly. And the rolling upgrades allows you to push your applications, and Service Fabric will automatically take down those pieces of applications one by one and direct the traffic with a load balancer to make sure that only the applications that are live should receive those requests. And as your application is upgraded, the other old instances of your application are going to be taken down. That guarantees an availability of your applications and allows you to scale out in ways that are not really possible in other scenarios. What also that allows you is resource governance. Resource governance is a kind of a fuzzy word, but basically what it says is it allows you to better balance your cluster. If you have 5 nodes or 10 nodes or 1,000 nodes of your Service Fabric, what you want to make sure is that you're not having all your application on one node. Because then the problem with one node is everyone is going to be using CPUs. If one service starts using a bunch of memory all of a sudden, all the other applications are going to be impacted. You don't want that. This is not something that's going to be fun. Your application is going to crash for a weird reason. So what you want to do is you want to balance your cluster. So all your applications should be on different nodes, so that when your new request comes in and that your application needs power, the cluster can actually provide it. What that also allows is better application density. By being able to split your applications and being able to fit many applications all together, and you can basically say, we're going to have multiple applications on this node, and not the same application on the other node. And that allows you to squeeze as much application as possible. And with the policy enforcement, what's going to happen with that is you can basically pre-say that to Service Fabric, well, I know that this application should not be using more than that amount of memory, and should not be using more than that amount of CPUs or amount of cores. So it's possible to tell Service Fabric basically to do not grant more resources to this application, because if it's using more resources than we think, it's probably in a fail state right now. And finally, Service Fabric brings stateful workloads. This is really special, and we're going to talk a little bit about it in a few seconds. But this is basically called reliable services, and that allows you to share state with different services that needs to store states. And this provides Service Fabric with an integrated solution for our Azure Services micro platform. So how does it work, a Service Fabric cluster in Azure? Well, a cluster supports thousands of nodes in self-repairing and scales and scale out. So if you look at your data center that is Azure or on-premise or on Amazon or anywhere, really, it doesn't really matter, you're going to have a bunch of VMs that are all going to be spread out. And what Service Fabric you need to do is you have to have it installed on each of those VMs. On Azure, we're going to take care of that with something like Azure Virtual Machine Skill Set. And all those service fabric are going to start to talk to each other and recognize each other and form a cluster. In front of that, we're going to put a load balancer and the whole world, because basically that's the web. And if you want to look at your cluster, you can always hit up on the port 19080, which is going to go through the load balancer and talk to Service Fabric directly, allows you to push your code, your applications, and everything else through Service Fabric. But as people try to request your application, either on the more standard ports, always going through the same load balancer, they're going to be automatically sent to the right VM. And they're going to be sent to the right services at the right node, and they're going to make sure that everything else, all of this scales. But Azure Service Fabric is not just for Azure. As you can see here, it's really for any OS or any cloud. Azure Service Fabric runs on your dev machines. It runs natively in Azure and can also be installed on your own on-premise infrastructure. And since this is basically a service you can install anywhere, it can be also used on other cloud services. And you can even use it on Linux. This was previewed recently. And it can be installed on any OS and any cloud. And to top all of that, this is, of course, going to be running containers and microservices as first-class citizen. So all of this, while always providing lifecycle management, always on availability, orchestration, programming models, health monitoring, all of these tools and all these foundations that are needed to run an effective applications. All of this is going to be provided with Azure Service Fabric, and it's all built in. But it's important to note that this is not a simple application. This is not something that is a pet project at Microsoft. This is something that is powering Azure. Service Fabric runs SQL database. As we're talking about 2.1 million database, and we're talking about Cosmos DB, which handles billions of transactions per day. IoT Hub is also powered by Service Fabric, which provides millions of messages per day. And Event Hubs, which at 60 billion events per day, is just crazy. But that's just developer tools. We're also talking about Skype for Business, Cortana, Intune, Dynamics, and Power BI. This is, like I said, this runs critical software. So this is a tool that is made to be reliable, to scale to incredible numbers, and if it serves Microsoft, it can definitely serve your business. So let's run a little demo. So let's get started with simple applications. So let me get back to the code. So I'm going to have a little app here. Let's just pull up a Service Fabric app. So, of course, let's just say I love bacons. Gonna love cap locks. So I love bacon. Let's vote bacon. And I love pizza, because who doesn't love pizza? Our deep dish pizza in Chicago is actually awesome. So I can keep on voting, and all of this is, of course, going to work. This looks like a simple .NET app, and it should, because it's really what it is. So let's look at the code behind, because this is definitely something we're going to be interested about. So we're going to start with a simple solution. So let's close all of this just to make sure that we're starting from scratch. And we have this project here, which is Service Fabric. And this is basically contains the parameters of for your deployment, the application manifest for the different way we go on to configure the cluster. So let's not look into that. Let's look at the front end, the website where we're actually going to be interested about. So this is a simple .NET Core application that is going to be connected. And it's the same old function and same old structure that you're all used to. So when we vote, and we can come back to the application and just do an F12. We're going to do a network operation here. We're going to track what's happening. And we're going to click, for example, on bacon. We can see here that we have a bacon. And the header, we can just see it's a put event. And this is just giving us bacon as a vote. And after that, we're just updating the count. We're doing a get on the votes, and we'll see how that goes. So if we're looking at the code itself, here we go. So what we have here is a vote controller. And let's start with actual putting the vote, casting the vote. This is the put methods. And this is going to take the URL of our service proxy and doing a put action on it and just returning the result as it comes in. Simple enough. And the get itself is going to call the same service proxy and just returning the result serialized properly. That'll be it. So what do you see here? Well, we see that we're calling localhost, which is weird because technically on Service Fabric, localhost is going to be the same machine. So how do we handle multiple nodes with localhost? Well, really, localhost is all about technically a local feedback loop. It's for it's a loopback, and this loopback is going to be automatically catched by Service Fabric and automatically routed to the right service. But this is with a service we call reverse proxy, and this is basically done on either a localhost or the name of your cluster. And this is going to be done by default on port 19081. And as you can see, the voting here is actually matching the name of our application deployment. And voting data is the name of our other application right here. And then after that is all our application as it is right now. So since we're all forwarding those requests to this proxy URL, I think we should take a look at this data and see how it goes. So the same thing is done. So we're reaching API and vote data. So this is also configured in the startup. And what's going to be interesting is the actual vote data controller. But there's something special about that vote data controller, is that this is a stateful service. And if we look at it, we're going to see a piece of code here that's called the reliability state manager. This is something that most of you have probably never seen before. So when we cast a vote, we're going to do a put again on the same endpoint. So how do we do that? Well, the state manager is going to be in vote, and we're going to create a reliable dictionary on the fly and just call it counts. It could be any names, but for us, it's going to be counts. And we're going to create a transactions. And the transaction is going to allow us to synchronize our operation with this reliable dictionary. Then we're going to add or update our application. And we can see here that it takes the transaction and parameters. It takes the key, which for us is going to be our vote, and then the initial value that we're going to add. But if the value already exists, we want to update. So this update value factory is actually going to be doing this. The old value is going to be added, and we're going to commit the transaction. So this is similar to a database, but we're doing it in memory. And all of this data is going to be synced across all instances. So what happened when we add vote left and right? This data is going to be synchronized. So even if we're under heavy load and we're synchronizing votes, all those are transactions and are going to be run as transactions on a reliable service. So in the end, even though we're being hammered with votes, we could always fall back and have this real data that's going to be synchronized and updated properly. But how do we retrieve it? So now, if we're looking at a get, we get the same stuff. We do the same. This piece of code is exactly the same as this one. So we're getting the votes dictionary again, and we're creating a transaction yet again. And from now on, it's just about building up a list up until we can add our elements to the list and serializing it back. And all of this will go back to our vote controller right here, and it's going to be serialized into a key pair value, which in the end is going to be what we see here in the response. So as we keep our votes, oh, I don't know what donor is. You guys are crazy. I love you. Never leave the open URL, right? So let's do this. So while you guys are voting, this is insane, and I'm going to love it. So I'm going to do a publish. And that's my next demo. I'm not going to switch to the slides. But basically what I want to do is I want to keep the version here, and we're going to increment it. Somebody's going to have to tell me what a donor is. It's probably amazing and tasty. I don't know. So basically what I just did is that we're going to upgrade the application. So what that means is that Service Fabric is actually going to make sure that all of our instances are going to be progressively rolled back. If you remember the rolling upgrades, this is going to happen. So we're going to start the publish right now because this is going to be a little bit longer. And there's 3 ways to upgrade an application in Service Fabric. And we're going to track it down in the output while it's going on. There's a managed upgrade, and it's going to be automatic, and it's going to make sure that your else check are actually running. So if you have else check in your applications, you can configure those into Service Fabric to make sure that your application is behaving properly. So even though you're publishing to the cluster, your health check is going to make sure that your service is running correctly. What we're going to do is we're going to go in an unmonitored version. So we're not going to do health check because those can take 20 minutes, and I only have so much time. So let's not do this. And so we're going to go in unmonitored, which is going to go a little bit faster. So what we can see right now going on in the window is we're done building the exe for the voting data and voting web. And we're starting to execute the script, which is deploy fabric application.ps1. And this script is available, and you can customize it. It's right over here. So this is the same script. We're not hiding anything from you guys. This is right there for you to look. All right, so we started copying the application. So I would love to actually just fall back to the cluster right here and see the voting type here. And this is our applications. You can see we're at 1.0.0, and we're in a stateless service. And I'm just going to go cast a vote because I'm pretty sure you guys, I'm going to go for, everybody loves bacon. You guys are amazing. It's insane. So as the application is going to be upgraded, we're going to see this upgrade, actually. And the application is being copied to the store right now. We're registering the application type. So we can talk about a little bit about the structure of the applications. So you see that the application here is technically a type. And this is important because, as you can see here, we're provisioning in the 1.0.1. And then there's the application itself, which is, by the way, has an upgrade in progress. It's a rolling forward in progress. And what's going to happen with the stateless service is that basically we're going to take down the nodes, but we're going to make sure that the reliable dictionary keeps its data. So if everything goes well and the demo gods are with me, we're not going to lose a single vote. And you know what? I'm going to vote for burritos because why not? It's awesome. So there's a lot. What is this, camoles? That's insane. So we're currently upgrading this live, and the cluster is upgrading right now. So we're rolling forward in progress. We can see the application is being upgraded progressively. This is going to go with upgrade domains. So each of your nodes are going to be assigned a domain. And each of those domains are going to be upgraded progressively one by one. And as soon as one domain is upgraded, it's going to start with the other one and progressively change the requests to the other nodes. So let's see where Visual Studio is at. So the application is, we're waiting for upgrade. The upgrade was successful, and we're all done. So technically, we should be in 1.1 very soon. Let's just crank that up. Yes, with 1.0.1, did we lose any vote? I think bacon is still the most popular. So what we did is we basically took an application that was running live, and you guys hammering it like crazy, like I see here. We have a strong competition with pizza. That's insane. And while you guys are hammering at it, we're keeping it up, and we're upgrading the application, all while you guys are still hammering it. If it's not crazy, I don't know what is. I'll just like leave out. So let's go to the next part. This is just insane. So let's keep going. So we did the upgrade. That was cool. So if you want to go microservices, what is the path? How did you get there? The main recommendation should be to use a monolith if you can. Because if you don't know how to build a monolith, you're not going to know how to build a microservice. So you need to know your application properly. You need to be able to understand the business need of your application and move forward with that before you even start considering building a microservice. So once your application is built, it's where you actually start to peel off the services. So if we take the same example that we had a little bit earlier with our eShop container, we had this awesome application that is multi-service, multi-facet of your business that is an e-commerce. And we built this huge monolith, and it's awesome. But suddenly, you see that every time people orders, you would need more power for the shopping cart, because this is just no way that you're going to be able to handle all of that, and you would need to scale up your application. The problem is that if you scale it up, you're scaling the whole thing. So the first step in going microservice is maybe I'll try to peel off the basket and just like take that out and ramp it up. So as you peel off this as a microservice, you can give it its own backend store, its own SQL database or MongoDB or whatever you want to use, and start building up just this specific service. And maybe you're going to have a team dedicated to that. And as you find other part of the application that could improve on just getting peeled off and spin off as single services, you're going to start finding patterns. You're going to start finding ways that your application can be scaled up just by taking one part of the application and just scaling that one out. If you're using a single page application, for example, the most requested file on your system is going to be index.html. This is the one single file that you're going to use. Do you really need to scale this file to 50 nodes? Probably not. And that file doesn't need to be on 50 servers. So you don't need to scale that one out a lot. But even if it's in .NET Core, even though it's still some memory, still some stuff, you don't want to have that on all the servers. So if you want to scale your catalog, that's something different. Because if you're loading a single page applications, well, you're going to have to do access on your catalog and see which products you have available. And by doing that, there's a lot of requests that are going to be sent to the database for the catalog. So you want to make sure that the specific catalog is going to survive. So this part of the application, since it's going to be used by 99% of your clients, this one you might want to scale to 50 nodes, because that's the most popular service. But the ordering service, how many percent of the people that goes to your e-commerce are actually ordering stuff? And that's where you actually see that not all services are created equal, and some needs to be scaled independently. And as you start to peel off service, you may find that maybe you cut that service a little bit too large. Maybe ordering and basket were the same service at some point, and you start peeling them off. This is number 3. And you go with smaller service as soon as you start hitting the sweet spot where you can actually scale your application properly. And finally, you can always go into containers. We have a great demo on our website where you can just take an application that is on a server right now and just put it in a container, in a Windows container, and lift and shift it to Service Fabric. Of course, this is the same scenario as the monolith approach. You were going to scale the whole application through all the nodes. But this is a valid answer to start creating microservices. As soon as you're on Service Fabric, there's nothing preventing you from adopting our different architecture for that and leveraging the nodes that we're providing for you. So talking about containers and our orchestrations, I know there's a lot of you guys that already watched a lot of presentation today on .NET Conf about containers and Kubernetes and all those different containers. But if you see Service Fabric and you look a little bit of what it does right now, is it takes a service, it takes your applications, and makes sure that it is always up, always running, and if it fails to upgrade, it automatically rolls it back, and it's basically an orchestration service. But the difference is that we're running executables and we're running .NET applications. But there's nothing preventing you from running a containers because we're just orchestrating executables. But then the question is, what is a container? So if you're just joining me just now, and you're going to need to watch back the other session, but let's keep on. And what is a container? If we're looking at very high level, of course, I'm talking very high level because there's people doing more than that. A container is basically your applications, an underlying application framework, and a base image. And the only thing that's going to change in this container is your image content. So as you can see, all your files and all your application is going to be on that same image. The only thing that's going to change is your applications. And that's the kind of thing we want to push, because then you can start reusing the containers and the base image, and you don't have to be that heavy anymore. How does Service Fabric and containers work? Well, Service Fabric provides native container support. So you have image deployment and activations. And we do support authentication with private registry. So if you have your own registry or even using the Azure registry, you can actually have your own containers. And to make sure that your application works correctly in the container world, in the service fabric world, we also provide an environment variable to provide inputs to the container. I'll have some demos on that in a few minutes. We also support volume driver support, so you can mount persistent drive. And in terms of networking, we do bridge network, mapping of container ports to dynamic port on host machines. We allow you to register on different endpoints. We have different services, either a naming service or a DNS service that allows you to resolve the other endpoint properly. And of course, since we talked about resource governance, we can apply that to container too. So you can definitely say, this container is going to use a little bit more CPU, a little less I/O. And if you want a best experience, I really recommend those two instances at the bottom here for containers. Those are VMs on Azure, and those are the recommended VM size for containers. And of course, we do support Docker Compose. So in fact, let's take a look at how it looks. So we're just going to go into the eShop containers. And this is basically this application that we're going to see right here. So I know you guys are going to hit on it, so I'm not even going to try updating it because you're going to just make it crash. But basically, this is the same stuff. And the same instances can be seen basically here. Are you guys killing this application right now? This is insane. So all of those here are basically the same containers and the same applications. So you can see we have all of our different APIs for the eShop container that we talked about, and all of those are separately deployed. And for example, if we take the basket API, we can drill down and see on which nodes they can be found. Same thing for SQL, RabbitMQ, and MongoDB. So how is this application built, really? So we started with a voting data app, and the voting data app is simple. There's a front end, there's a back end, and really there's not much more. There's a single point of data, and we want to go a little bit further. So let's take a look at how this application is structured. So we have it, if we go from the start, we have a Docker Compose file, which can allow you to have all your images, all your tags, everything is there. All the images are, by the way, public. And all of this is going to be what we're going to be publishing to Service Fabric. All of those applications here are each have their own application package root with their own configuration and service manifest. And we're going to take an example, for example, to the catalog. So let's take an example, for example, let's go with the MVC app because I don't want to start finding code. And we're just going to look at a catalog controller. So we're going to talk to a catalog service. So this is, by the way, a properly architectured microservice that can be found on GitHub. So we're just going to go into the iCatalog service. And we can see that we're using an HTTP client to do request on our catalog URL. And the same API in V1. This is versioned, and everything is working fine. So this is hitting on our settings, and is in the catalog URL. So our settings is a representation of this code here, and they can be found here when you're working localhost. But the thing is, what if you're building up a container? Well, you're going to want to talk to the catalog URL, right? So the MVC applications that is right here will need to know about it. So when we publish to this cluster, we're going to be able to pop up the config, wrong file. And we're basically going to be doing what is called the DNS service. And we assign different DNS like this to the service when we want to make sure that we're accessing the proper service in a different way. We can use both reverse proxy and the DNS service. This is interchangeable, but this is, I think, easier to use. And it's more clear in terms of URLs, what you're actually hitting on. So in this case, we're using the DNS service to access all of this. And the catalog API, eShop Service Fabric, and all of those each have their own DNS assigned to them. So this is what is going to be pushed and deployed when you're pushing to Service Fabric. And this can be overridden too by the Docker Compose file. So once we're done, we can see here the ASP.NET Core URLs that we're going to be deploying on is going to be listening on port 80. This port is going to be used after that to load balance. And all of this can be seen on the Azure portal right now. So if we're taking a look at what does a deployment of a cluster looks like, this is a sample cluster that I built. This is built on a virtual machine scale set. And by the way, you don't need to create all those resources yourself. All of those are going to be provided when you're starting a new Service Fabric cluster. And it's as easy as doing add, and then typing Service Fabric, and the cluster, and following the steps. There's many steps, and like I said, if you guys, my goal here on Microsoft as a developer advocate is to make the experience better for you guys. So if there's anything in there that is not up to snuff or something that you think we could do better, please feel free to contact me. I'll put you in contact with the right people, or better yet, I'll make sure to drive this issue forward for you. And let's not create a cluster because I already have one. And creating a cluster can take a little bit of time, especially if we have something like a virtual machine scale set. As we can see here, we have 8 instances, which is the same stuff that we have here on Service Fabric in the cluster. Yeah, I get warnings. I don't know why. And as you can see, I'm pretty sure this right now is when you guys started hitting the API and trying to kill my app while live. We can see all the instances that are currently running. And of course, that's the best part. We can scale them up. But if we come back to the load balancing, and all those rules are not hidden inside Service Fabric. They're visible in the portal. So that's something you can actually see. So there's a front-end configuration with all of our stuff in there. So all the rules are all there. But let's take a better look. So if we're looking at the load balancing rules, all of our apps each have their own port that can be accessed, and all of those can be accessed directly. And you can customize those different configurations yourself, and there's nothing preventing you from adding or removing nodes. And of course, all of this is also available through Visual Studio. So it's always possible through the Cloud Explorer to just do more with the virtual machine scale sets. So let's keep things forward. So publishing an application like this is super easy. Basically because you don't have any code really to push, because once your image are published, they're going to get sent, the compose file is going to be sent to Service Fabric. Service Fabric is automatically going to pick up your compose file and try to build the image. So it's going to download the actual file. So here are the things that can be problematic. If you're running a Windows Server images tends to be big. And if an image server is big, Service Fabric is going to have to download them. And if they have to download it, we're talking about downloading maybe a few hundred megs, or if your image is a few gig, you can expect the deployment of an application that is changing a lot to actually take a little bit of time in the beginning, especially if you have a large image. If you're publishing Linux VMs, then it's always possible to have smaller images a little bit, because they've always been known to keep under the 700 megs, because CD, yeah. And so deploying a Docker container is always dependent a little bit on the speed of your and the size of your VMs. You want to keep those small. This is always a consideration that you want to do. So we talked a little bit about the containers, but we didn't really say anything about ASP.NET Core yet, or Service Fabric for that matter, with ASP.NET Core. So how does it integrate? Well, first you're going to have your MVC web applications, or seriously any other kind of applications, like a web API or front-end service. And this application is then going to have a lot of other APIs in the back. And Service Fabric is going to wrap all around those. And Service Fabric is going to orchestrate all the calls to those applications. But really, how does hosting .NET Core and Service Fabric works? Well, you can do either a container as a guest exe, or you can host it in a reliable service. So the web host is it's a single process. It's just like a guest executable. And the main host process of Service Fabric is going to invoke is going to create a core process. And this core process then is going to either be a web listener or server with Kestrel, or it's going to run your whole application altogether. In a reliable service way, the program main is going to register your service type, and the Service Fabric runtime is going to spawn a new instance on your cluster, and the iCommunication listener is going to start listening to all the calls. So ASP.NET Core itself is not relying on the HTTP sys stack to handle everything. Service Fabric is going to handle that, and it's going to route the call now to the ASP.NET Core, and then the ASP.NET Core is going to forward all of this to the server, Kestrel, or web listener. So really, Service Fabric and .NET is, for me at least, the best way to run microservices. But as we also saw, since we're all running containers and we're running guest executables, there's really nothing preventing you from running a Golang executable or just running any other kind of platforms in there. As long as you can run it, you can basically host it in the Service Fabric. And Service Fabric is going to make sure that your service is going to stay up and rolling upgrades is going to be taken care of, and that you're never going to get down on your luck, on your applications. So to finish it off, what I really want you to do, guys, I want you to try it out. I want you to go to those URLs. First, to install the SDK. Because if you want to run this application on your machine, you might need the SDK to make it work, to at least make the experience a little bit easier. So I want you to go to those links, click on them, and try to see if you can install it and make it work. Any feedback on those documentations or the actual service, I'm gladly going to take and drive the issue forward for you guys. Then I want you to learn from samples. So if you want to see samples, you can go to this link, and you can also try Azure Service Fabric. There's things that are called party clusters that were launched a few years ago, that if you don't want to go through the whole installation of a Service Fabric cluster, there's already clusters that are free for you to try, where you can just build a sample application and host them on a public cluster. Of course, I would highly recommend you, please, that you don't run critical business out of those clusters, mainly because those are going to be wiped on a periodic basis, and you don't know who else has access to those clusters. And if you don't secure your application properly, there's always a possibility that you're going to lose data. So if you can try it out, that would be awesome. Also, it is very important to know that the Service Fabric team is highly active on Stack Overflow. So if you do encounter any issues, those guys are going to answer like all the time on Stack Overflow. They are scouring Stack Overflow for problems, and they're going to be there for you. You can always add to the forums, or if you really have an issue, you can go on GitHub, and there's a specific repository where you can log your issues. And on that note, my name was Maxime Rouillet. I'm still a cloud developer advocate, and I will gladly take your feedback. You can either send me an email or hit me up on Twitter. Actually, I'm going to answer way faster on Twitter because I'm a social media addict. I don't know, maybe. And I want you to go also to the docs. If you can go to the docs and tell me what do you guys think, because we're all under docs.microsoft.com now. And if you go to aka.ms/sfdocs, I'll gladly take any feedbacks you have for you guys. I really want to make sure that Service Fabric is the best product we have for microservices.